I actually wrote down the parallel, equivalent, and opposite information from the other side to help us with this graph right here. Ooh, my coffee's hot. Ooh. All right, so use the graphs below to classify each pair. So we have A. I'm going to highlight these as we go, which is not going to help. Okay, so you have A, and you have E. Okay. It's going up 1 over 2, down 1 over 2. So same or opposite direction. They have the same exact length. So for that reason, these are opposite. Now you can find that by actually calculating it. We're just going to kind of play the guessing game here. Okay. I and F. So here's I, and here's F. Okay. Heading the same exact direction, going up 1, 2, 3, 4, 5, 6 over 2. 1, 2, 3, 4, 5, 6 over 2. Same direction. Okay. They're going to have the same magnitude. So for that reason, they are equivalent. I'm just going to write equal. Same thing. All right. We have D and we have E. They're not the same size, so they're not the same magnitude. But they are going the same direction. So I'm going to highlight that. That's parallel. Okay. And then we'll highlight this one. B and G. So we have B and we have G. Okay. It's going down 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So they have the same like distance, but they're kind of going about things oppositely. But they don't have the same magnitude. We're not guaranteed that. So this one's actually none. And they're not heading in opposite directions, so that's why it's not opposite. And these aren't heading in the same or complete opposite directions, so that's not it. And then since that doesn't match at all. And then last but not least is C and H. Okay. So C and H are looking like they have the same magnitude, but they're going in opposite directions. So this is a opposite. All right, so there's that. All right, moving on. Proving that vectors are equivalent. So proving that vectors are equivalent. There's two things you have to know. Okay, they have to have the same magnitude. So using what we did on the other thing, on the other side, the first video, and they have to have the same direction. Wow, that was really crooked. So that's how you use the slope. So we have like 4 things to do for this problem. That is a horrible line. I just can't make straight lines. It's just not a thing. All right. We're just going to separate our work. Okay, there we go. All right. So, pen. All right. First thing we're going to do is we're going to figure out if the magnitude's the same. So that's the distance formula. And then we'll figure out if the direction is the same. So there's no point of finding one of each and then moving to the next, because if it fails at the magnitude, then you can obviously say that they're not equivalent. So to find the magnitude, technically it's at double bar AB, and we're going to take 3 minus 7, which is adding, and you're going to take negative 2 minus negative 6, which is adding, and you get 10, which is 100, and this would be 4, so that'd be 16, and I wrote 116. All right, so if you were to simplify that, it's 116. We're going to divide it by 2. 116 divided by 2 is 58. Divide that by 2 and you get 29. And that gives you 2 square root of 29. So we have to see if CD has that same situation. Okay, so you're going to do 0 minus 10, which is adding. And then you're going to do 6 minus 2, which is 4. So if you notice, we end up with 116, because it's 116, which was the same as what we had here. So right now the magnitude is the same. So right now, I'm going to highlight it green. We're good to go with this one because they both equal. Okay, now moving on to the other one. we have to find the slope, and hopefully you remember how to find the slope. So it's y2 minus y1, x2 minus x1. So we're going to take 0 minus 10, which is adding 10. Oops, I did that backwards. Ooh, ooh, ooh. Back up, back up, back up. I wanted to do AB first. Oops. Okay. Go one more step. Okay. This is AB. So if I do AB first, I go 3 minus negative 7. So 3 plus 7. And then you're going to do negative 2 plus negative 6, which is negative 2 plus 6. So kind of like the numbers we already did. And that gets you 10 over 4, which is 5 halves. And then you have to do the slope for this one. So you're going to do 0 minus negative 10, which is positive. And then you're going to do 6 minus 2, giving you 10 over 4. So that's 5 halves. So if you notice, the slope is exactly the same. So because the magnitude and the direction is the same, you have equivalent. I'm going to write that therefore. Therefore, they are equivalent. All right, moving on. All right, so standard form. What is standard form? Standard form is when the initial point of a vector is at a point, is at the origin, okay? So you can see that in the thing right there, we're at the origin, okay? If the vector v is in standard position with a terminal point AB, right there, ending point, then the component form of it is v equals, and these little weird sideways carets, okay? So that's the component form. I'm going to highlight that. Voila. Okay. So the magnitude and direction of a vector can be given in component form and can be found using the following. So we kind of already talked about the magnitude being written this way. I hinted at it without you realizing it when I wrote a squared plus b squared. Okay, so that's the magnitude. And then to find the directional angle, you're actually going to use tangent. So we haven't escaped it yet. Tangent of theta equals b over a, and that's because it's y over x. And if we think about it, this would be the b and this would be the a. So we're kind of finding slope of it basically, but they're finding it with an angle, okay? Because it has to have the same angle, and the same angle would be the same slope. So find the magnitude and direction for each vector. So let's separate this. And let's do magnitude first. So these ones are easier in component form, I think, because it's a lot less work. It doesn't matter the order of how you do this, but it'd be 7 squared, which is 49, and 24 squared, which is 576. Okay, so 49 plus 576 is 625. And the square root of 625, just want to check, is 25. So the magnitude of this is 25 units. Don't know what the length on it, but we're putting units. Then we want to find the directional angle. So we do tangent of theta. We're trying to find theta. And we're going to do b over a, which is the same thing as y over x. And you have 24 over 7. Okay, this is where we do that inverse tangent. I'm going to jump right into it. So we do inverse tangent of 24 over 7. Your calculator needs to be, oh, there you go. It needs to be in degree mode. And I'm going to go to 4 decimal places, so 74.7398 degrees. Okay. I want to see if you can try number 10 on your own. See how far you can go. If you get stuck, restart the video. If you get done with it, fast forward the video and check your answer. All right, so pause the video now. All right, now that you restarted the video, and that was probably quick. Hopefully you didn't even pause it. I don't even know. Let's go over each one of these. That line is way crooked. Whew. Oh well, we're gonna keep on going. Okay, so we're finding the magnitude of this, which doesn't really look like double bars, but it is. We do 3 squared, which is 9, 1 squared, which is 1, so that gives us the square root of 10. We can't simplify it, so I'm going to just put the units label on it. And then we're going to find the directional angle. So we'll do tangent of theta equals -1 over -3. Well, negative divided by negative is a positive, so we don't need that. And so we do inverse tangent of 1/3. So second tangent of 1/3 4 decimal places, and you get 18.4349 degrees. All right, so not too bad. That's the second video. We're going to go ahead into the third video here in a little bit. So just hit the little thing that's going to come up the corner of my screen and move on to the next one. All right.